Hi everybody, today we are going to talk about our next type of quadrilateral, which is a rectangle. Now hopefully we remember that a rectangle falls under the category of parallelogram. So a rectangle is going to have all of those same properties that we talked about yesterday. Okay, so some important facts about rectangles. Rectangles are actually a type of parallelogram, so they have all of the properties that we talked about for parallelograms. So if we have rectangle A, B, C, D, some of the things we could mark in is that AB is parallel to CD, BC is parallel to AD. We know that the opposite sides are also congruent. We know that opposite angles are congruent, consecutive angles are supplementary. We also know that the diagonals will bisect each other. Now, rectangles also have two additional properties that are really important to know. The first one is what really dictates the fact that it's a rectangle, and is that all angles are right angles. So we know that all four of these angles are 90 degrees. So we know that angle A, angle B, angle C, and angle D equal 90 degrees. The other important fact to know about rectangles is that not only do the diagonals bisect each other, the diagonals are actually congruent. So we can conclude that diagonal BD, which is from here to here, is actually congruent to diagonal line segment AC. So like I said, they are congruent, but we also know that they still bisect each other. So we actually know that all four of these segments are going to be congruent. So that's going to be a really, really useful fact about rectangles. All right, let's try using some of our new rectangle facts. So this first one, I'm going to zoom in a little bit. We are told one of the angles in this rectangle, and just from one angle alone, we can find all of the other angles, which is really awesome. So let's give this one a try. So as you can see here, the one that we are given is the measure of angle 1. So let's start with one of our parallelogram facts, which also applies for rectangles. We know that in rectangles, the opposite sides are parallel. We also know that the opposite sides are congruent, but that's not going to help us in this type of problem. So if we are told that angle 1 is equal to 30 degrees, I can use these parallel lines because we have parallel lines cut by a transversal. So if you remember, when you have a situation like this, there's a lot of different angle relationships which are useful. So we actually know that angle 1 and angle 5 are congruent because they are alternate interior angles. So that's going to be really useful for us in this problem. So we know that angle 1 is congruent to angle 5. And once again, we know that they are congruent because they are alternate interior angles. So we know that angle 1 and angle 5 are both 30 degrees. Now let's use one of our new rectangle facts. We know that because the diagonals of a rectangle are congruent, all four of our segments are going to be congruent. So if you look at what we have here, we actually have 4 different isosceles triangles. So here you can see one of those isosceles triangles. So since our triangle is isosceles and it has 2 congruent sides, it's also going to have 2 congruent angles. So we also can conclude that angle 1 is congruent to angle 8 because it is an isosceles triangle. There we go. So I know that angle 1 is congruent to angle 8, and then I know that angle 8 should be congruent to angle 4 because they are alternate interior angles, or I have another isosceles triangle on the bottom. So from this alone, we already know 4 of our angles. We know that angle 1, angle 4, angle 5, and angle 8 are all equal to 30 degrees. Now let's use another rectangle fact. We know that in a rectangle, all of our angles are equal to 90 degrees. So we know that angle 1 plus angle 2 should equal 90. Well, we already know that angle 1 is 30. So we know that angle 2 is going to equal 60 degrees. Now angle 2 is 60 degrees. And we know that there's a lot of angles that are congruent to angle 2. Angle 2 is congruent to angle 6 because they're alternate interior. Angle 2 is congruent to angle 3 because this is an isosceles triangle. And angle 6 is congruent to angle 7 because that's an isosceles triangle. So all 4 of those angles in red are equal to 60 degrees. So angle 2, angle 3, angle 6, and angle 7 are equal to 60. Now from here, we just need to find those angles in the middle. So let's look back to this triangle that I highlighted up top. We can use the triangle sum theorem to find angle 11 because we know that the 3 angles in a triangle should add up to 180 degrees. So angle 1 plus angle 8 plus angle 11 equals 180. We know that angle 1 and angle 8 are both 30. So if we combine like terms, we can solve for angle 11, and it should equal 120. Now angle 11 and angle 12 should be congruent because they are vertical angles. So we'll give it 3 arcs. Oops, sorry, 120. There we go. Now the last 2 we need to find will be angles 9 and 10. So I can do this in 2 different ways. Either we can use the triangle sum theorem again, so we can do angle 2 plus angle 3 plus angle 10 equals 180. Or we can use the fact that we have a linear pair right here. We can say, let me write this down. For a linear pair, we can say angle 11 plus angle 10 should equal 180 degrees. Linear pairs are supplementary. We know that angle 11 is equal to 120. We just found that. And so we can solve for angle 10. And we know that angle 10 is equal to 60 degrees, which means that angle 9 is also equal to 60 degrees because they are vertical angles. So angle 9 and angle 10 equals 60. So just from one angle, we have managed to find all of the other angles in our rectangle. All right, let's try another one together. Here we are told that ABCD is a rectangle. That's going to be really useful. We are also told that AC, which is a diagonal, is 30 minus x, and BD is 4x minus 60. So we know that since this is a rectangle, that our diagonals are congruent. Since the diagonals are congruent, well, we can conclude that AC is equal to BD. We know that AC is 30 minus x, and we know that BD is 4x minus 60. So from here, I can solve for x. I'm going to add x to both sides, and then I'm going to add 60 to both sides, and then I'm going to divide both sides by 5. And we get x equals 18. And we're done. Now we did need to know a very important fact about rectangles, and that's the fact that the diagonals are congruent. If we didn't know this was a rectangle, we wouldn't be able to solve this problem in the same way. Okay, let's try this last one together. So here we are told that once again we have a rectangle, which will be very useful. We are also told that NR, which is a diagonal, is 2x plus 10, and we're told that NP, the smaller segment, is 2x minus 30. Okay, so since this is a rectangle, we know that all of the parts of the diagonals are going to be congruent. We know that the diagonals are congruent, and we know that the diagonals cut each other in half. So that means that we actually know that all 4 of those segments are 2x minus 30. Now, we know that the full diagonal is 2x plus 10, so we can create an equation to solve for x by saying 2x minus 30 plus 2x minus 30 equals 2x plus 10. We're essentially doing small part plus small part equals big part. So let's combine like terms. 4x minus 60 equals 2x plus 10. Here, let's move 2x to the other side. We'll subtract 2x from each side. And I'm going to add 60 to each side. So we get 2x equals 70. Divide both sides by 2, and x equals 35. Now remember, we weren't asked to solve for x. We actually were asked to find MP. Now MP is one of the halves of a diagonal. So I know that MP, just like our other segments, is going to be equal to 2x minus 30. So since I know what x is, I can do some substitution, and I can conclude that MP is 70 minus 30, which is 40. All right, why don't you go ahead and pause the video and give this one a try. This is just like that first example that we did. So try to work your way through all of the angles, given that angle 7 is 25 degrees. Okay, so here you should end up with angles 1, 4, 5, 8 being 65 degrees, angles 2, 3, 7, and 6 being 25 degrees, angles 11 and 12 are 130, and angles 9 and 10 are 50. All right, here's one last problem that I would like you to try. So here we are told that ABCD is a rectangle, so that's good. We know that AB is 4 and BD is 3. So we know that the opposite sides are going to be congruent, so we can mark these up. And we are trying to find BC, which is this diagonal. So when I draw that diagonal, you'll notice that we have 2 triangles, and even better, if you know that one of the properties of a rectangle is that all angles are 90 degrees, we actually have 2 right triangles. So here we can actually use the Pythagorean theorem to help us find our hypotenuse. So we can just do a squared, so 3 squared plus b squared, which would be 4 squared, equals c squared, which is x squared. And all we have to do is solve for x. So 9 plus 16 equals x squared. 25 equals x squared. Square root of 25 equals x. And we know that the square root of 25 is 5. So BC actually equals 5. So it's really important to always look for ways to create right triangles, because we know that we can always use the Pythagorean theorem. All right, that's all for today. Thank you for watching.